I want to thank Vanitech and the committee for the invitation. Today, I want to talk about the progress we have made here in China regarding VFB and energy storage. Could you turn the page? Could you turn the page? Okay. Before I formally start, let me tell you something about myself. I got my PhD back in '08, and then I joined the Dalian Institute of Chemical Physics. At the institute, I did a lot of research and development on VFB, and then the technologies became more mature, and then we started a company doing VFBs at the institute. So at that time, my job was transferred to the company making VFBs. Back in 2020, I joined the Dalian Marine University to continue my research and development on VFBs. Could you turn the page? Could you turn the page? So we have done a lot of research on key materials, including electrolytes, ion exchange membranes, electrodes, and bipolar plates. In the past, there were very few companies of VFB materials here in China. Now, there is more players in the market, and we have seen a lot of progress in making all those key materials for VFBs. Could you turn the page? When I work with the company, I am in charge of R&D, so my work involves a lot of different things, including the battery stacks, battery systems, and the mass production of products. We have implemented over 30 energy storage projects in VFBs. Could you turn the page? Could you turn the page? Thanks. So we have received a lot of honors and awards, as you can see here. We have won the second prize for National Technical Inventions, the CES Outstanding Science and Technology Award. Could you turn the page? Thanks. So now let me get to the point. I'm going to talk about the progress we have made in China regarding using VFBs for energy storage. So back in 2020, President Xi Jinping delivered a key speech entitled Carrying Forward Our Task in Responding to Climate Change. And in China, as you know, we have our goals regarding carbon peaking and carbon neutrality. So those goals actually demonstrate our responsibility as a large country. Could you turn the page? Please turn the page. Thanks. As you know, renewable energy such as wind and solar have a lot of shortcomings. They are not continuous. They are intermittent. They are unstable. If we are to use those sources of energy on a large scale, we got to depend a lot on energy storage. And energy storage technologies could have a major bottleneck for new energy. So we need to do more research on energy storage technologies so that we can develop new formats or new forms of energy storage. Next page. At the second session of the 14th National People's Congress this year, Premier Li Qiang delivered the government working report. In that report, there was a lot of mentions regarding new energy storage, flow batteries, and compressed air energy storage have been gaining attention. Next page. In all the provinces and municipalities, we have seen new measures taken. For example, in Guangdong, there is a new policy regarding the high quantity growth of new energy storage. And by 2027, the total value of new energy storage in Guangdong will reach 1 trillion yuan. In Guangzhou City and Shenzhen City, the governments have set up new energy storage funds worth 10 billion and 20 billion yuan respectively. Next page. When we talk about energy storage technologies, we need to understand the difference between those and power battery technologies. So here, safety is a priority. Also, we need to achieve energy storage of a large capacity over a long time. Safety sometimes could be a big problem. So back in 2017 and 2019, South Korea saw over 20 explosions at energy storage facilities. So also, we got to consider the issue of pollution. We need to ensure that we can recycle VFBs safely without causing major pollution. And also, cost effectiveness matters. We got to make sure we have economical solutions in developing VFBs. Next page. Next page. Thanks. So just now, I talk about three major aspects. What's the biggest advantage of VFBs? Safety. So normal temperature, normal pressure, and controllable temperatures without any flammable gases. It is, it is very, I mean, VFBs may break down, but there won't be any explosions. And as for the electrolyte can be recycled. So we could see that using VFBs for energy storage, we can avoid wasting a lot of resources. And we can define this as a non-resource consuming industry. And that means a lot for sustainability. And as for cost effectiveness, the major problem is that the initial investment could be high. However, the total life cycle could be high, up to 10 or even 25 years. So we need to address the high initial investment. Next page. So how can we lower the initial investment? The initial investment is a one-off investment. In that one-off investment, the electrolyte accounts for 50 or even 60% of the total cost. As I mentioned, the electrolyte is recyclable. And then that means VFBs and VFB projects have the financial property. How can we understand that? What's the financial property in this?
The one-time investment can be recovered by 50 to 60%. That is the financial aspect. And if you buy new products, you can only buy other parts 50 to 40% other than the electrolyte. So therefore, the investment cost is lower. And lastly, the financial aspect is about the funded leasing. That is the financial attributes. So we have to wait for the battery market to grow to a certain level so that the leasing of electrolyte to be viable. Once that is available in the market, when we phase out the old electrolyte, we can start the recycling of electrolyte. Then this model we believe is viable. Next slide, please. There's a wide application for the fluid batteries as shown in the previous slides. It can be applied in the grid, in the energy generation, as long as there is a solar and wind power generation. it is very much necessary to have the large scale and long-term energy storage solutions. At the same time, it can solve the safety concerns of national grid. This requires energy storage technologies is more about the society, but also viable to the industries. So people are really closely watching the development of this industry. It can be at a magnitude of more than trillion RMB. That is the estimate. Next slide, please. The flow battery was invented or proposed in 1985. It has experienced its peaks and downs. So it was Japan has a very good development. And then it got stuck for a while, and now it was developing again. So in China, we have more than 100 flow battery manufacturers, especially in recent years. Since 2023, we have more than 20 gigawatt hours of flow battery projects, which has been registered. And also the supply chain of flow batteries have been increasing, especially for the raw materials and the plates, the electrolyte. So those are four elements. We have more and more downstream and upstream manufacturers, which has promoted the rapid development of a flow battery. The current funding is more than 5 billion since 2023. As we have more players in the supply chain, the companies have announced to expand their capacities. Altogether, the total planned capacity is more than 20 gigawatt, which is a large number. Next slide, please. Among all the flow battery companies, we have the liquid flow batteries that are most vanadium flow batteries. That means it is one of the most sophisticated technology and also validated by the marketplace. And also we have other types of flow batteries, such as zinc-based flow battery, iron-based, and new flow batteries. All of those flow batteries, they are designed to address the high cost issue. That is the gist of survival. However, they are presented with great challenges. For example, the cost per kilowatt, the stability, durability, they need to address that issues. Therefore, their technologies are not as sophisticated as the vanadium flow battery. They have to utilize other energy storage projects to prove that they are viable and feasible. Out of those solutions, vanadium flow battery is the most sophisticated one. Next slide, please. And if we look at the 1 megawatt and 4 megawatt vanadium flow battery, the current price is 2,000 to 2,500 RMB per kilowatt. You can see electrolyte accounts for the major trunk. In order to reduce the cost, so companies have come up with different solutions. First is around the electrolyte. The companies can have in-house electrolyte manufacturing, or they can cooperate with vanadium manufacturers to have a lower cost to produce electrolyte. Secondly, on top of the technology based on the first generation, companies are doing the short process electrolyte preparation technology. It is estimated to reduce the cost by 20 to 30%. So this will further drive down the cost of electrolyte. In addition to that, a major part is the pile or battery stack. So we have three major parts, which is the plate and the film. So they respectively account for 30%, and the membrane accounts for 30%, the electrode 20%, and also the bipolar plate 20%. in order to develop the new generation of those key materials will be important to drive down the cost. Next slide, please. In addition to drive down the cost of the material, we can also think about improve the power density, which is another way. So in China, the battery stack is on another way. We have already been through the 30, 40 kilowatt or even more 100 kilowatt can be achieved. The different metrics can be at an international leading position. At present, while we increase the scalability, we have already entered the era of high power density. Now we can do 200 to 300 MA per square meters. In the laboratory, from the literature studies, we can achieve in the lab a current density of 500 milliampere per square meters. And we can see there's a lot of potential for future cost reduction. Next slide, please. Here, I would like to share with you some case studies. This is a Dalian Rongke energy storage project in 2012. It was the 5 megawatt hours and 10 megawatt hours. That was in 2012. And then it was the single largest project. It has been 12 years. Now it's still in normal operation. The efficiency and capacity remain the same. So through this project, it is proved that the durability and service life has been proved for vanadium flow battery. Next slide, please. This project is also a 2012 project, 100 and 400 megawatt hour project that was in the city center in Dalian. It is safe to assume that it is currently world's largest energy storage project. It has multiple technology iterations. It has explored different large-scale energy storage technologies and their functions. It has played a very important role because this project has laid China's leading position in the world. Next slide, please. Just now, I have shared with you the development of flow batteries. Despite of the great achievement that we have done, however, before 2021 or 2022, the industry was about to be bankrupted. But because of the safety issues, the flow batteries have gained exponential development in recent years. However, the time is relatively short. So we have many capitals going into these industries. Many companies were set up before there's a frenetic investment. We see there's a mismatch of the supply chain and the supportive system. We do not have enough talent and experience, equipment, and the material. So in terms of those elements, we do not have sufficient resources to work with so many companies. And so now people are fanatically expanding the capacity. Next slide, please. Therefore, in 2024, the biggest problem faced by the flow battery company is the difficulty to deliver. How to understand that in a short time, in a short period of time, we have so many companies who joined the business in 2 to 3 years. They do not have a sophisticated manufacturing process and sophisticated qualified products. So there's a high cost of errors. The technology is viable. However, I have to emphasize not all the companies can do that. because some companies are presented with great operational challenges. Among all those companies, who can really stand out among others? Well, it depends on the advanced technology, the technical reliability, massive production maturity, and the maturity of product maintenance to solve the R&D to achieve massive production with good quality. Next slide, please. So far, we have had the acceleration for flow batteries, but let's not be optimistic and pessimistic. Why we shouldn't be too optimistic? Because this is current a buzz industry. The reasons for the industry not to develop in the past are still there. Currently, it is only popular and trending because of the safety attribute. But how long can it be? How popular can it be? It depends on the technology breakthrough in the flow batteries and what are the advantages come with that. So we need to remember this aspect, but let's not be too pessimistic because we already been presented this opportunity to develop with the injection of human resources and the capital. We have so many staff and companies to join this industry. We need to seize those opportunities with the empowerment of the capital. We should make the breakthroughs, get the technologies to get the approval from the market. However, it takes time. It takes a process. Well, we can also go through fluctuations. The companies should really be ready and be ready for investment in the R&D for the flow battery so that we can achieve the industrialization. Next slide, please. With that, I conclude my presentation. I would like to thank you. We are specialized in the flow battery research and industrialization research. If you are interested in this regard, you're welcome to reach out to me anytime. Thank you.
Thank you. Mr. Ma, there is a question in the Q&A. If you could please go there and try to answer, that would be great. We're going to need to move on, though, in the interest of time. Thank you very much. A great presentation. It's very exciting to see all that's going on in China as China is really leading the world in the deployments of vanadium flow batteries.